Section 10 of Gray's Anatomy, Part 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Morgan Scorpion. Anatomy of the Human Body, Part 1, by Henry Gray. Bone, Part 1. Structure and physical properties. Bone is one of the hardest structures of the animal body. It possesses also a certain degree of toughness and elasticity. Its colour in a fresh state is pinkish-white externally and deep red within. On examining a section of any bone, it is seen to be composed of two kinds of tissue, one of which is dense in texture, like ivory, and is termed compact tissue. The other consists of slender fibres and lamellae, which join to form a reticular structure. This, from its resemblance to lattice work, is called cancellous tissue. The compact tissue is always placed on the exterior of the bone, the cancellous in the interior. The relative quality of these two kinds of tissue varies in different bones, and in different parts of the same bone, according as strength or lightness is requisite. Close examination of the compact tissue shows it to be extremely porous, so that the difference in structure between it and the cancellous tissue depends merely upon the different amounts of solid matter, and the size and number of spaces in each. The cavities are small in the compact tissue and the solid matter between them abundant, while in cancellous tissue the spaces are large and the solid matter is in smaller quantity. Bone during life is permeated by vessels, and is enclosed, except where it is coated with articular cartilage, in a fibrous membrane, the periosteum, by means of which many of these vessels reach the hard tissue. If the periosteum be stripped from the surface of the living bone, small bleeding points are seen which mark the entrance of the periosteal vessels, and on section during life every part of the bone exudes blood from the minute vessels which ramify in it. The interior of each of the long bones of the limbs presents a cylindrical cavity filled with marrow and lined by a highly vascular areolar structure, called the medullary membrane. The strength of bone compared with other materials. Substance: medium steel. Weight in pounds per cubic foot, 490. Ultimate strength pounds per square inch. Tension: 65,000. Compression: 60,000. Shear: 40,000. Substance: granite. Weight in pounds per cubic foot, 170. Ultimate strength pounds per square inch. Tension: 1,500. Compression: 15,000. Shear: 2,000. Substance: oak, white. Weight in pounds per cubic foot, 46. Ultimate strength pounds per square inch. Tension: 12,500. Footnote: indicates stresses with the grain, i.e., when the load is parallel to the long axis of the material, or parallel to the direction of the fibres of the material. End footnote. Compression: 7,000. Shear: 4,000. Footnote: indicates unit stresses across the grain, i.e., at right angles to the direction of the fibres of the material. End footnote. Substance: compact bone, low. Weight in pounds per cubic foot, 119. Ultimate strength pounds per square inch. Tension: 13,200. Compression: 18,000. Shear: 11,800. Substance: compact bone, high. Weight in pounds per cubic foot. Left blank. Ultimate strength pounds per square inch. Tension: 17,700. Compression: 24,000. Shear: 7,150. Periosteum. The periosteum adheres to the surface of each of the bones in nearly every part, but not to cartilaginous extremities. When strong tendons or ligaments are attached to a bone, the periosteum is incorporated with them. It consists of two layers closely united together, the outer one formed chiefly of connective tissue, containing occasionally a few fat cells, the inner one of elastic fibres of the finer kind. forming dense membranous networks, which again can be separated into several layers. In young bones the periosteum is thick and very vascular, and is intimately connected at either end of the bone with the epiphyseal cartilage, but less closely with the body of the bone, from which it is separated by a layer of soft tissue, containing a number of granular corpuscles or osteoblasts, by which ossification proceeds on the exterior of the young bone. Later in life the periosteum is thinner and less vascular, and the osteoblasts are converted into an epithelioid layer on the deep surface of the periosteum. The periosteum serves as a nidus for the ramification of the vessels previous to their distribution in the bone, hence the liability of bone to exfoliation or necrosis when denuded of this membrane by injury or disease. Fine nerves and lymphatics, which generally accompany the arteries, may also be demonstrated in the periosteum. Marrow. The marrow not only fills up the cylindrical cavities in the bodies of the long bones, but also occupies the spaces of the cancellous tissue and extends into the larger bony canals, Haversian canals, which contain the blood vessels. It differs in composition in different bones. In the bodies of the long bones the marrow is of a yellow colour and contains, in 100 parts, 96 of fat, 1 of areolar tissue and vessels, and 3 of fluid with extractive matter. It consists of a basis of connective tissue supporting numerous blood vessels and cells, most of which are fat cells, but some are marrow cells, such as occur in the red marrow to be immediately described. In the flat and short bones, the articular ends of the long bones, in the bodies of the vertebrae, in the cranial diploe, and in the sternum and ribs of the marrow is of a red colour, and contains in 100 parts, 75 of water, and 25 of solid matter consisting of cell globulin, nucleoprotein, extractives, salts, and only a small proportion of fat. The red marrow consists of a small quantity of connective tissue, blood vessels, and numerous cells, some few of which are fat cells, but the great majority are roundish nucleated cells, the true marrow cells of Colica. These marrow cells proper, or myelocytes, resemble in appearance lymphoid corpuscles, and like them are amoeboid. They generally have a hyaline protoplasm, though some show granules either oxyphil or basophil in reaction. A number of eosinophil cells are also present. Among the marrow cells may be seen smaller cells, which possess a slightly pinkish hue. These are the erythroblasts or normoblasts, from which the red corpuscles of the adult are derived, and which may be regarded as descendants of the nucleated coloured corpuscles of the embryo. Giant cells, myeloplaxes, osteoclasts, large multinucleated protoplasmic masses are also to be found in both sorts of adult marrow, but more particularly in red marrow. They were believed by Colica to be concerned in the absorption of bone matrix, and hence the name which he gave to them, osteoclasts. They excavate in the bone small shallow pits or cavities, which are named Howship's foveolae, and in these they are found lying. Vessels and nerves of bone. The blood vessels of bone are very numerous. Those of the compact tissue are derived from a close and dense network of vessels ramifying in the periosteum. From this membrane vessels pass into the minute orifices in the compact tissue, and run through the canals which traverse its substance. The cancellous tissue is supplied in a similar way, but by less numerous and larger vessels, which, perforating the outer compact tissue, are distributed to the cavities of the spongy portion of the bone. In the long bones, numerous apertures may be seen at the ends near the articular surfaces. Some of these give passage to the arteries of the larger set of vessels referred to, but the most numerous and largest apertures are for some of the veins of the cancellous tissue, which emerge apart from the arteries. The marrow in the body of a long bone is supplied by one large artery, or sometimes more, which enters the bone at the nutrient foramen, situated in most cases near the centre of the body, and perforates obliquely the compact structure. The medullary or nutrient artery, usually accompanied by 1 or 2 veins, sends branches upward and downward, which ramify in the medullary membrane, and give twigs to the adjoining canals. The ramifications of this vessel anastomose with the arteries of the cancellous and compact tissues. In most of the flat, and in many of the short spongy bones, one or more large apertures are observed, which transmit to the central parts of the bone vessels corresponding to the nutrient arteries and veins. The veins emerge from the long bones in three places. Colica. 1. One or two large veins accompany the artery. 2. Numerous large and small veins emerge at the articular extremities. 3. Many small veins pass out of the compact substance. In the flat cranial bones the veins are large, very numerous, and run in tortuous canals in the diploic tissue, the sides of the canals being formed by thin lamellae of bone, perforated here and there for the passage of branches from the adjacent cancelli. The same condition is also found in all cancellous tissue, the veins being enclosed and supported by osseous material and having exceedingly thin coats. When a bone is divided, the vessels remain patulous, and do not contract in the canals in which they are contained. Lymphatic vessels, in addition to those found in the periosteum, have been traced by Cruikshank into the substance of bone, and Klein describes them as running in the Haversian canals. Nerves are distributed freely to the periosteum, and accompany the nutrient arteries into the interior of the bone. They are said by Colica to be most numerous in the articular extremities of the long bones, in the vertebrae, and in the larger flat bones. Minute anatomy. A transverse section of dense bone may be cut with a saw and ground down until it is sufficiently thin. If this be examined with a rather low power, the bone will be seen to be mapped out into a number of circular districts, each consisting of a central hole surrounded by a number of concentric rings. These districts are termed Haversian systems. The central hole is an Haversian canal, and the rings are layers of bony tissue arranged concentrically around the central canal and termed lamellae. Moreover, on closer examination it will be found that between these lamellae, and therefore also arranged concentrically around the central canal, are a number of little dark spots, the lacunae, and that these lacunae are connected with each other and with the central Haversian canal by a number of fine dark lines, which radiate like the spokes of a wheel, and are called canaliculi. Filling in the irregular intervals which are left between these circular systems are other lamellae, with their lacunae and canaliculi running in various directions, but more or less curved. They are termed interstitial lamellae. Again, other lamellae, found on the surface of the bone, are arranged parallel to its circumference. They are termed circumferential, or by some authors primary or fundamental lamellae, to distinguish them from those laid down around the axis of the Haversian canals, which are then termed secondary, or special lamellae. The Haversian canals, seen in a transverse section of bone as round holes at or about the centre of each Haversian system, may be demonstrated to be true canals if a longitudinal section be made. It will then be seen that the canals run parallel with the longitudinal axis of the bone for a short distance and then branch and communicate. They vary considerably in size, some being as much as 0.12 mm in diameter. The average size is, however, about 0.05 mm. Near the medullary cavity the canals are larger than those near the surface of the bone. Each canal contains one or two blood vessels, with a small quantity of delicate connective tissue and some nerve filaments. In the larger ones there are also lymphatic vessels, and cells with branching processes which communicate, through the canaliculi, with the branched processes of certain bone cells in the substance of the bone. Those canals near the surface of the bone open upon it by minute orifices, and those near the medullary cavity open in the same way into this space, so that the whole of the bone is permeated by a system of blood vessels running through the bony canals in the centres of the Haversian systems. The lamellae are thin plates of bony tissue encircling the central canal, and may be compared, for the sake of illustration, to a number of sheets of paper pasted one over another around a central hollow cylinder. After macerating a piece of bone in dilute mineral acid, these lamellae may be stripped off in a longitudinal direction as thin films. If one of these be examined with a high power of the microscope, it will be found to be composed of a finely reticular structure, made up of very slender transparent fibres, decussating obliquely, and coalescing at the points of intersection. These fibres are composed of fine fibrils identical with those of white connective tissue. The intercellular matrix between the fibres is impregnated by calcareous deposit which the acid dissolves. In many places the various lamellae may be seen to be held together by tapering fibres, which run obliquely through them, pinning or bolting them together. They were first described by Sharpey, and were named by him perforating fibres. The lacunae are situated between the lamellae, and consist of a number of oblong spaces. In an ordinary microscopic section, viewed by transmitted light, they appear as fusiform opaque spots. Each lacuna is occupied during life by a branched cell, termed a bone cell or bone corpuscle, the processes from which extend into the canaliculi. The canaliculi are exceedingly minute channels, crossing the lamellae and connecting the lacunae with neighbouring lacunae and also with the Haversian canal. From the Haversian canal a number of canaliculi are given off, which radiate from it and open into the first set of lacunae between the first and second lamellae. From these lacunae a second set of canaliculi is given off. These run outward to the next series of lacunae, and so on until the periphery of the Haversian system is reached. Here the canaliculi given off from the last series of lacunae do not communicate with the lacunae of neighbouring Haversian systems, but after passing outward for a short distance form loops and return to their own lacunae. Thus every part of an Haversian system is supplied with nutrient fluids derived from the vessel in the Haversian canal and distributed to the canaliculi and lacunae. The bone cells are contained in the lacunae, which however they do not completely fill. They are flattened and nucleated branched cells, homologous with those of connected tissue. The branches, especially in young bones, pass into the canaliculi from the lacunae. In thin plates of bone, as in the walls of the spaces of cancellous tissue, the Haversian canals are absent, and the canaliculi open into the spaces of the cancellous tissue, medullary spaces, which thus have the same function as the Haversian canals. End of section 10.